In today's session, we are going to look at how to divide, all right, in polynomial functions. Okay, so assuming that you have something like this, which is x cubed plus 4x, all right, square minus 7. You have x square minus 3. Now, usually when it comes to the polynomial function, the division aspect, the division is done using long division. But let me quickly chip in this. We have an aspect whereby we call it the improper function. So for instance, what I'm trying to say is that let's say you have 5/2. This one is called improper fraction, all right? You have 1/2. This one is called proper fraction. Now, why the difference? It is improper because the numerator, which is the top one, is bigger than that of the denominator, which is the down part. So it becomes improper. One of the ways to identify whether the function is actually improper or proper is when the degree, or let me say here, the highest power for the top one is 3. The highest power for the down one is 2. Okay, power 2. Meaning that because the power is higher than that, top one is higher than that of the down part, we call this one improper function. All right, so I'll come back to that. When you have an improper function, how do you go about it? But first of all, let's focus on how we can do the division. So here you have x cubed plus 4x squared. Let me bring you 0 here, x, all right, minus 7. You are the one introducing it, okay? And you have x squared minus 3. So this one is called divisor. That is what is dividing this one. So you start with this. X squared will divide the x cubed. So that will give you x. What this one means is that x cubed on x squared. You have x times x on x times x. So this one will cancel. What is left? X. So that is what the division is about. Now, immediately you get that this one will come and multiply what you have here. When it multiplies it, what do you have? You have x cubed. That same x will also multiply what you have over here. But what do you have? It is giving you negative 3x. So you will not bring it down here. We've already done the addition, the subtraction, the multiplication. But here, I need you to understand something. When this one multiplies, it's giving you negative 3x. So you will not bring it under the x squared. So you can just put 0 over there. Then you have negative 3x. So what happens then is that you subtract. When you subtract, this one will affect this, giving you negative 3. So it will become x exponent 3 minus x exponent 3. And that side will give you 0. So now let's say that this was x squared. 0 plus this, all right? The negative will affect it, but 0 from this is still the same. So you have 4x squared. Then the negative will make it positive, plus this, that will give you 3x. Okay, then you bring this one here, which is next 7. Afterwards, the same divisor will come and divide the x here, will come and divide this one. So that will give you what? 4. So you have 4x squared on x like this. It will cancel, giving you what? 4. And that's why it's 4 there. So the 4 will multiply this, giving you 4x squared. The same 4 will multiply this, giving you that is neg 12. Okay, so you will subtract negative 4x. All right, subtracted from that, that will give you 0. Negative, when you subtract this one from this, you have plus 3x. The negative will affect this one. That will give you positive. Then you have this, so you have plus 5. Now, because this one is power 2, ideally, when you try to let it divide this one, it will be a little bit of a challenge. So what we say is that this one is what? A remainder. Okay, so what I'm trying to bring your attention here is that when you have an improper function, like with respect to polynomial, and you are supposed to divide, what you are going to have is that you are going to have what you call quotients, okay, then you will have, that is a remainder, okay, then you have what you call the divisor. All right, so where is the remainder? This one. So that become 3x plus 5. Then the divisor, which is x squared minus 3. Then where is the quotient? This side is the quotient, so that become x plus 4. So that is what this one will give you. That is the division of this. This is what it will give you. And that is if you have an improper function or fraction in the form of polynomial function. Now, sometimes too, is such that it may not necessarily be an improper function or fraction. However, the way it is, it requires that you also apply wisdom to get the same thing that we are looking at. Let's look at the second question. So you have x plus 4 divided by x plus 1. Now look at the TS power 1 power 1. But how do we go about with it? So you can, like that's why I said you apply wisdom, okay? So you look at it carefully, then you write, okay, x plus 1 plus 3. So that this 3 plus the 1 will give you the 4. All divided by x plus 1. Now watch it. What it means is I can rewrite this one as x plus 1 on x plus 1 plus 3 on x plus 1. Sorry, 1 here. They will cancel. That will give you 1 plus 3 on x plus 1. So what I'm saying is that there are instances too that the fraction may not be an improper fraction. But when you have it in this way also, you can also go about with it. Somebody may say, but what you've done, can you actually get back this? Yes, that is, let's say you have LCM 1 here. This, that will become x plus 1, all right? This multiply this, you have x plus 1. This one here, 1. And you have plus 3. You put together, you have x plus 4 on x plus what, 1. So if you want it back, when you simplify, it will give you what you are looking for. All right. So this one too is like you have what? The quotient plus the remainder. Then you have the divisor. This is the divisor. This is the remainder. And this is kind of the quotient. All right. Now let's look at this one also. You have x squared plus 3 on x squared minus 1. Now you can see that here the power is 2 power 2. So they are not necessarily improper. All right. So you look at it carefully. Look at it carefully. Then you can see that, okay, here I can write x minus 1. All right. To seal this plus 4 all divided by x squared minus 1. So you can do it as x squared minus 1, x squared minus 1 plus 4 on x squared minus 1. So that this one and that will cancel. You have 1 plus 4 on x squared minus 1. So like how we did this one too, if you want to find out whether what you've gotten is correct, then you can just try and multiply, add it. That you are using the addition. Here you have x squared minus 1 comes here. You have x squared minus 1. Here you have 1 plus 4. You have x squared. When they add, you have plus 3 on x squared minus 1, which is similar to what you have over here. So what I'm trying to say is that when you have it this way and the powers are kind of the same, so they are not necessarily improper function or fraction, you can apply wisdom and go about it this way without necessarily dividing. Please, I hope you get it. Now let's look at the last one. So guys, we'll be solving a lot of examples. We'll be looking at questions from different angles. Polynomial actually covers a lot, okay? So kindly be following. If you have not followed our page, kindly subscribe to our page, all right? Follow our page, share the videos to your colleagues, your friends, All right, now let's look at this one also. You have x squared plus 2x minus 8. We are to divide. So when you look at it, you can see that clearly the power here is bigger than that. So this one is the denominator, this one is the numerator. Okay, so here you have x plus 4. Let's divide. This one comes here, that will give you, that is x times this is x squared, x times this is plus 4 x. All right, you subtract, so here we get 0, and this one will subtract, so that will give you negative 4 plus this, so you have negative 2x, and you have negative 8. This one comes here, you have negative 2 times this is negative 2x, negative 2 times this is negative 8. So this example 4.2 is also to explain to us that it is not all the time that you work it out to get a remainder. Sometimes, I mean, it will divide it exactly without a remainder. Okay, so for example, you have 8 over 2, it giving you what, exactly 4. But let's say you have 9 over 2, it will divide, let's say 4, probably point something. So that point something now is what, the remainder. All right, so with this one, you want to subtract. Negative is positive. You will have what, negative 2 plus 2x, so that will give you 0. Negative is positive, so you have negative 8 plus 8, and that one too is also what is 0.